We've described Level 3 strategies, seen examples of them, and considered the big ideas underpinning those strategies. Now it's time to examine some specific and systematic ways in which Level 3 strategies can be developed in our learners. In this lesson, we'll be examining how classroom routines can be used systematically to build Level 3 methods that lead to fact fluency. The classroom routines that we discuss will serve as a reinforcement for Level 3 methods. They are still whole group though. And then in the next lesson, we'll examine reinforcement strategies that shift to partner work and individual work. And then in the final lesson, we'll consider strategies for assessing progress. Our focus then in the next two lessons is primarily on the distributed practice phase. The assumption is that the target strategy has already been introduced and explored with concrete experiences and visual tools. However, sometimes new strategies are proposed by students during classroom routines, and in that case, children will still need to go back and work on exploring why it works if it's initiated by a student. Once a strategy has been explored, you may have some children who naturally seem to use their existing fact knowledge to just start deriving new facts using that strategy. However, I think you'll probably have many students who would never think to use that strategy again if you didn't cue it. And so they need some systematic plans in place by which the new strategy becomes an intrinsic part of their repertoire that can be used flexibly when the conditions allow for it. So the next two lessons provide guidance for how we can continue to build and reinforce those new strategies so that they become an active part of a student's schema. As we examine these routines, consider the use of visual images, because if a child cannot see why a strategy works, they will not be able to understand it or explain it, and it will likely not really develop as part of their regular repertoire, or else they might use it inappropriately as just a set of rules to be applied, even when they don't understand it. That is actually quite dangerous. On the other hand, children have the capacity to amaze us with their strategic thinking when they are using visual representations to notice things. When you want to introduce a new strategy, or when a child introduces a new strategy and you want the classmates to have some insight into what that discovery involved, a visual image can be very helpful. On this slide, you see an image of a child showing 9 fingers. This actual incident was inspired by a first grade child I knew a few years ago. We had played Parcheesi doubles for a while, and I noticed that some of the learners were not being stretched by the game anymore. We were playing with dice that went up to 6, and those doubles they had down pat. So when she easily knew her doubles through 6 plus 6, and some other students did, I made an accommodation so that those children could now play the game together using polyhedral 10-sided dice with new facts coming up. Since it was the first time they were playing it, I was overseeing the game to make sure they were off to a smooth transition, and this little girl rolled a 9. For just a moment, she looked a bit startled, sort of deer in the headlights. Then she put her hands out to show 9, trying to think of a strategy. As soon as she looked at her hands, there was really only a momentary pause, and she said 18. And so as part of the game, the students always have to explain their strategy, and she said, well, I could see that 9 is 5 and 4. See how her hands naturally decompose the 9 into a 5 and a 4. She says, if I just double the 5, that's 10, and then if I double the 8, that's the 4, that's 8, and then 10 and 8 is 18. So she was able to construct the strategy for herself using that visual. And her strategy was then able to be shared with the class using the visual to justify it, and they could decide whether they agreed or disagreed with it. Number talks are one of my favorite ways to foster derived fact strategies through a distributed practice opportunity. While I used to think of basic facts work as sheer drudgery growing up, number talks are actually quite enjoyable for learners. Kids love them. They are a low-risk environment for children to try out their budding ideas about fact strategies. By low risk, I mean that there's no grade and there's no teacher judgment. It is short, about 5 to 10 minutes, so it can easily fit into your daily schedule, and it's entirely driven by students' own ideas. As the teacher, you provide the prompts and the tasks which you think will elicit some good student ideas. And you typically have a very specific idea in mind that you hope that task will draw their attention to. It's up to the students to share their thinking and to reach a consensus about whether something works or doesn't work. A good number talk engages everyone initially by starting with a familiar or easy task. This task is easy and therefore it's the launch for strategy development. By starting like this, you don't have people phasing out on you right from the beginning thinking that they won't be able to do today's lesson. You sequence the tasks then in such a way that they gradually grow more difficult, but also they are allowing the earlier tasks to support them with the tasks that come later. So the first task that's easy is not just any random easy task. It is an easy task that gives a chance for the schema that will become useful to be brought up into their minds. Now, it is quite possible that students will not necessarily choose the strategy that you had in mind. Since it is student-driven, we accept all of the strategies as long as they work, and we ask students to build consensus about whether this works or doesn't work, trying to justify those. And this is where the teacher plays the second important role. The first role was in choosing the tasks and the task sequence. The second one is in eliciting the student thinking and pushing that thinking. So you can ask questions like, well, how did you think about this problem, Jose? Or can you explain Joey's strategy in your own words, JJ? Does anyone disagree with what Krista's saying here? So you're really trying to pull in a lot of student engagement, student involvement. How do you know? How did you think about this? Do you agree? Why or why not? Kinds of things. While you probably cannot dedicate more than 2 to 3 days for the introduction of a new strategy, Number Talks can pick up where you leave off with your lessons, using very short distributed practice sessions to reinforce that new strategy. These targeted Number Talks can then extend for the next few weeks, perhaps 3 times a week, with the other days of the week providing opportunities such as games and other kinds of targeted practice in 10 to 15-minute sessions. Over the first couple of weeks, the Number Talks should come at the strategy with different visual representations. That way they get a chance to see it maybe with 10 frames and a math rack and dot cards, and so they see a variety of different ways of thinking about it. Initially, the focus may be primarily just on examining those visual representations and talking about what's going on with the quantities. But then soon you're going to use those visual representations and use the students' comments about them to convert it to an equation. So working from the visual first to an equation, and then eventually the Number Talks shift to being entirely in equations until you start a new strategy, and then the new strategy starts right back at concrete again. All right, we want to take a look at how this might look in practice. So we're going to look at a sample Number Talk string. A string is a sequence of tasks. And we're using a visual representation, of course. In this particular example, we're using a visual representation to bridge to an equation. The visual tool is a math rack, although sometimes you hear it referred to as a rekenrek. That's the Dutch term because it originally started in the Netherlands. If the math rack is new to you, take a moment to look at it here. The version that you see here is currently reading 0 because you only read quantities that are on the left side. The 5 red, 5 white structure allows young children to use 5 and 10 as landmark numbers, and then the 2 rows lend themselves to working with 2 addends. Each version of the math rack that we show will be done as a quick image, so you can have a little cloth that you use to cover the math rack, or if you're doing it on the smartboard, you can use the screen to hide it while you make the adjustments, although in the smartboard you'll actually have just the next screen. The first task is not just any easy task we can think of, as I mentioned. We intentionally choose to elicit some thinking that could be useful in today's sequence. So the students should easily be able to see when you flash this image at them that it's 5 on top, 5 on the bottom, and then they can construct an equation, 5 plus 5 equals 10. Which I then write on the board. I don't spend a lot of time on this first task because it's mainly to pull out their schema, but it could implant the idea that 10 might be a useful number in today's Number Talk. Because the number talks always start fairly easy, use the easy tasks to build a bridge to the hard tasks and are in a string. Students pretty quickly pick up on that pattern and they begin to know if there's going to be something here that I can use to help me with the later things. Now I would cover up the math rack after flashing it for a brief time, and then I uncover it after they have their solutions and we can talk about it. But I would cover it up again, make an adjustment, show them the next screen, which is here. Children might notice that one of the beads on the bottom row has left, but another bead has joined the top row. Again, I show it as a quick image and then cover it. So they have to see these images fairly quickly without counting by ones. This particular one gets at the idea of compensation. Instead of being 5 on top, 5 on the bottom, one new one joined the top, one left the bottom. So the total quantity remained the same. This builds an idea called compensation, and that's important, but it also does it still with a familiar fact, because 6 plus 4 is a sum of 10 that they should be familiar with. Now, if they learn them just by rote, then 5 plus 5 equals 10 seems like an entirely separate fact than 6 plus 4 equals 10. But this two math rack sequence that you just saw now helps students see how they're related. One addend increased by 1 and one decreased by 1, and the total sum stayed the same. That's a pattern we can talk about, explore, think about why it works, decide if it always works, and how would we justify that. Now I flash the next image. We've been working with sums of 10, and this is one also, but I've skipped ahead in the sequence. This is also intentional. The children don't know it yet, but we're going to use 9 plus 1 as this fact right here in the next sequence to apply a level 3 strategy. So this implants the idea that just one more is all we need to get a complete set of 10 on the top row. Next, I flash this image for a moment. Notice that the top row is 9, and it only needs one more bead to complete its group of 10. The bottom row is 6, but I can easily use the visual format of this math rack to see that 6 is really 5 and 1, because I just see the one lonely little white bead there. So it sort of implants this idea that I could give that 1 from the 6 to the 10, and to the 9, and that would make it 10. So these visual images reinforce and implant the idea of what you could do, and then I'm going to use the children's own ideas to record it in terms of some equivalences, some equations format. But the whole idea that I'm eliciting for them is that 6 could be broken apart into two numbers, one of which will complement 9 and allow it to be a sum of 10. Now that they have the idea for the plus 9 fact, can they extend it to a plus 8 fact? Can they see that moving the 2 on this one from the 7 on the bottom up to the 8 on the top converts the whole problem into 10 plus 5? So that would be where I would go next. And then our last sequence will be looking at a plus 9 fact again, although this time it's actually the same fact as before, but instead of 9 plus 6, it's 6 plus 9. So that gives the students a chance to see that it works both ways and to begin to explore and talk, or actually not begin, but to continue the discussion of the commutative property. So that sequence that we just talked about, it gives you an example of a number talk string that could be used to build a bridge to writing equations. And then I would probably follow this up by having them notice each of our completed equations and talking about what they noticed in the way of patterns, if they have any mathematical ideas or things they notice that we could discuss. 10 to 15 minutes, and you can see how powerful that is in the short time. Eventually, as we continue to explore Make 10, we transition into using just equations. Initially, the visual tools are needed to construct the equation and make sense of it. But now you should have those mental images. You should have done it for a couple of weeks. You had tens, frames, dot, cards, math, racks. You came at it in a number of different ways. Now it's time to start looking at what can we do with the equations and how can we be strategic with the equations. Again, though, notice that here the string still works in a very similar fashion, with the first item in each string, first task, being very easy. Pulling students in, I know I can do this, I see, so that everybody can do it. It's a low judgment place, but yet that first task gives them a bridge to the subsequent ones. And again, you can see that these are still focused on a Make 10 strategy. Now, once you've developed the idea of how these number strings work, you can create them for yourself. But I know that initially that can be a bit intimidating, and there are some great commercial resources out there, which I'm including at the end of this lesson, showing them to you. And these strings here came from a Sherry Parrish book that I'll show you. The previous string, the idea for the sequence, came from another resource I have in here, although I did the commentary. Okay, there are other times of the day that can also be used to foster level 3 methods leading to fact fluency. So we're going to take a look at a couple of those options now. Attendance can be accomplished using particular math tools that allow the quantity of students to be perceived in different ways. This shows the attendance on 10 frames, but you can also use a math rack to take attendance. And this shows them the students being split into boys and girls, but you could use other types of things as well, those wearing red and those not wearing red, for example, to distribute the quantity between the 10 frames. As part of the morning meeting, you can have students share different ways in which they saw the quantities, and this can be used to generate number sentences, as shown here. If you do the attendance on a smartboard, you can visually draw the whole class's attention to how the different components of the equation make sense given the representation, as shown here. So when a student says they saw it a particular way, you can have them go back and tell you where in the picture did you see that. Dot cards, dice images, 10 frames, these are examples of other visual images which can also be used as quick images during down times of the day, even if those are just very small moments. For example, the dot card at the top can be used when students are standing in line, for example, or when they are at their seats and they've finished a lesson really early and you want to quickly do something just a little different before going into the next task. Notice when you look at this quick image at the top, you can show it not long enough to count the dots, but just show it. That's a quick image. And then you can put it down and you can say, think for just a moment. Okay, how did you see the dots? And some of the students here may actually see the dots as a 6 and a 1 on the bottom. So then they see the whole thing as a doubles plus 1, 6 plus 6 plus 1. But you may actually have some students who see it as a 6 and a 4 and a 3. Either way, you get 13, but you see a couple of level 3 strategies for how to do that. Oh, one more thing I wanted to show you at the bottom. These +9, +8 cards at the bottom also lend themselves to Make 10 strategies, and those are other things that you can show students during these down times and have them quickly construct. Can you do this quickly, like a quick image? And then what strategy did you use? Those can happen at any moment of the day. They take really just a matter of less than a minute to pull one of those out at different times of the day, and I'll include those in the resources, the teaching resources for this lesson. So here are the commercial resources I was talking about. The number talks are the Sherry Parrish book. The Rec and Rec sequence, or the Math Rack sequence that you saw, came from the book here. Mini lessons, actually it should be mini lessons for early addition and subtraction. And then the Origo Education offers the Book of Facts and the Box of Facts, which have a lot of resources for introducing strategies with dot cards. And so these are some